Well, once again, welcome to the webcast, and let's get started because we've got a lot of great content to share with you today, delivered by some very auspicious guests. And just to frame why Sustainable Minds is into the education marketplace, aligned with our mission about bringing environmental sustainability into mainstream product development and manufacturing, which is ultimately to impact the jobs that we create and the economy in which we live. And I think based on the attendance and based on the customers and the schools who are already using Sustainable Minds, there clearly is a very strong trend to integrate environmental sustainability into all types of curriculum: business schools, engineering schools, design schools, architecture schools. And I believe that the schools are realizing, and it's happening, that those schools who are integrating environmental sustainability into curriculum are attracting more and possibly even better students to meet the demand that industry is demonstrating. And the manufacturers who understand that competing, integrating environmental sustainability into their brand and into their products will innovate and grow, and they will recruit the students coming out of the programs that are readying individuals to participate in this new economy. So with us today, we are really fortunate to have three folks from UC Berkeley: Dave Dornfeld, who is the chair of the Mechanical Engineering Department and the director of the Laboratory for Manufacturing and Sustainability; his colleague Margot Hutchins, who is a research engineer and lecturer and the associate director of the lab; and Cindy Bayley, a graduate student at UC Berkeley and summer intern at Sustainable Minds for 2 summers. And I think you'll be very interested to see how Dave, Margot, and Cindy have evolved their use of Sustainable Minds at UC Berkeley, and how Cindy has brought her experience from working with us over the course of several summers into developing new curriculum for UC Berkeley. The way that we have structured today's presentation is Dave will start out by talking about what's happening at UC Berkeley in mechanical engineering and tell you a lot about the lab. Then I'll tell you about Sustainable Minds. There's a lot of people on this webcast who are familiar with Sustainable Minds and many who are not. And so we'll do a brief overview of the product and the content that comes with the product, so that sets the context for Margot introducing the Sustainable Manufacturing course and starting to give you some insights into the 3 types of projects that they've developed, and 3 types of curriculum using Sustainable Minds. And Cindy will wrap things up with her updated and enhanced version of one of the projects already in the curriculum, and then we'll move to a Q&A. We will take your questions during the webcast. Everyone is on mute, but if you check your control panel, there's a questions box. Type your questions in at any time, and we will take them at the end. Any question that you submit that doesn't get answered, we will follow up with you offline. So without further ado, I'd like to turn things over to Dave Dornfeld, Chairman of the Department of Mechanical Engineering and Director of LMAS. Take it away, Dave.
Thanks, Terry. So we're really pleased to be here and participate in this webinar. As you said, we've got a lot of material to cover, so we'll try to cut right to the chase. Let's see. We're learning how to run the machinery here. So it's interesting. I'm not going to read through all this, obviously, but everyone at Berkeley and its students pretty much in mechanical engineering in most U.S. universities are trying to make things. The designer, the make movement, tech shop movement has come full force. As part of that maker movement, everybody's interested in figuring out how to design products that are more energy and resource efficient, more sustainable, if you will. So it's a great opportunity to have this enthusiasm building on the part of the students, undergraduate as well as graduate students, and of course industry reflects that as well. So I come at this with a manufacturing focus, as do my two colleagues here, meaning that eventually you have to produce products, and eventually there are impacts caused by the production operation, and eventually there are impacts on how these products are used. And we want to try to make sure that when a design is realized, produced, manufactured, that we have taken into consideration, along with the usual quality, throughput, reliability, cost, etc. constraints, issues of resource efficiency and effectiveness. So that's sort of been an area of interest to me for about the last 15 or 20 years, and it wraps nicely over more traditional areas of focus. A little bit of background about mechanical engineering at Berkeley. I think compared to some of the Big Ten schools, I graduated from Wisconsin, we have a smaller program, although its enthusiasm pushes more and more students, about 600 undergraduates. We've got about 370 or so graduate students, and they're all taught and mentored by some 46 faculty members. If you're curious, a POG is a professor of the graduate school, so when someone retires, they can still maintain active involvement in research, not so much in teaching and administration by becoming a professor of the graduate school. So this leverages the folks who've had a very long and productive career. And we have 22 staff members, of course. Mechanical engineering is something that requires practice, both mechanical, computational, etc., experimental. So those people are very important to keep the place running. The coverage in mechanical engineering these days covers the full gamut, right? I mean, you have, of course, the importance of information technology for systems and sensors. You have biotech, energy, environment, transportation, and then the core areas sort of in the very center, traditional areas of mechanical engineering. Berkeley tries to emphasize social impacts to a great amount in the work that's going on, so things that map onto healthcare and quality of life, energy, safety, security, things like that, built on a platform of both science-based and practice-based engineering education. So you can always check it out on the website, but it covers a broad area of activity and reflects a lot of the research going on by industry in the West Coast and the Pacific Rim that we serve with our students and our activities. So I'll talk a little bit about the Laboratory for Manufacturing and Sustainability. It became apparent, as I said, probably 15, 20 years ago when I was on sabbatical in Europe, that companies were beginning to embrace the concerns about resource utilization, energy efficiency, material efficiency, end of life, processing characteristics, safety and security of the employees and their customers and the environment. And it also seemed like this was a good time to go into that from the point of view of what was going to be happening in the United States. Much of it is driven first by energy concerns, and you can map that onto global warming and environmental issues, but there's also, as manufacturing people, the concern about materials and resource effectiveness, utilizing materials in the most productive way so you get, if you will, the largest value for the of a product that's created and manufactured for the impact on the environment or social infrastructure or whatever the area of focus is. So that's what our laboratory focuses on. I also, sort of just to help educate or publicize the comments and get feedback from people, I started writing a blog a couple of years ago with the address is shown there, and that is a place that I talk a little bit more about trying to communicate with a broader range of folks, public, about the interface between technical policy, social issues related to green manufacturing, why it's important. Many people thought, well, manufacturing doesn't have much to do with environmental or green impact, so why do we worry about it? So part of the reason was to try to show people that there is a reason to concern about it. And then there's a Facebook page, of course, social media. I'm not a tweeter yet. I don't think I will be a tweeter, but I suppose that'll come at some point. So to really do this right, one should think about a holistic view, meaning that you would like to say, if you do sort of a Google Earth view of manufacturing, you start at a fairly high level, enterprise, the facility, the corporation, you zoom into a factory, you zoom into a system or a line in the factory, and you zoom lower into that system and line to a machine or a set of machines that are programmed to do certain functions. And on that machine is a process or processes, and the process is enabled by sets of tooling. And the interesting thing is that if you focus on any one of these areas, you can find different and often compelling reasons to green the process or to analyze the energy or resource utilization and see if we can improve upon that. At the same time, of course, while maintaining the requirements of the design process. A lot of this these days, so the cloud is everywhere, right? So data interoperability, communications at all these different levels. So one should take advantage of that, map them onto design tools like Sustainable Minds or more product design tools. And then wrapping around the outside of it, you should really begin to consider social impacts. And this is a tough one for engineers to draw the thin line between when I design a product and I specify how it's going to be made and select material. How do I actually understand the sort of collateral social impacts, whether it's in the factory or it's in my community, or whether it's somewhere in the supply chain, you know, something being mined over in some other part of the world, and if that is being mined in a sustainable fashion and treats the employees correctly, because eventually all of these things get tied together. Companies are being measured more and more on how well they are guardians of the supply chain and ensure that the product that is delivered to the customer is both energy efficient, meets the functional needs, cost effective, safe, but also doesn't cause problems throughout the supply chain. And you know, one can decide how you want to address those things, but ultimately engineers have to make those decisions and figure out what they do at the machine and factory and the system and enterprise and tooling level and how that might have some social impact. That's a complicated one, but that's an area that we're putting more and more attention on because it sort of ties everything together very, very nicely. Just a little bit of a word from our sponsors, if you will. We have a range of projects that we are working on. I characterize them in terms of tools that we provide. Some are technologies, meaning ways in which you can improve manufacturing technology to build energy efficient products or systems, like a project we have funded by DOE on artificial photosynthesis. You have a whole set of analytical or assessment tools or software. So we don't make software, but we like to make modules and define things that fit within other people's software that can help to bring the green assessment or sustainability assessment to the engineer. Or we help define companies' interest in trying to do trade-offs on process technology, which is better or worse if I swap one technique versus another. We look at planning and optimization. A number of companies are working with us on that for the design of systems or design of devices. There's an emphasis on clean tech to some extent, looking at technologies that are specifically clean. And of course, we partner with the campus people on education and with some people in the business school on business drivers. So range of companies supporting our work, developing software and tools and techniques that can be scaled across many different applications. When I started doing this, I tried to build an argument as to why industry should pay attention to the manufacturing part of green or sustainable impacts. The top bullet, of course, is one that a lot of people relate to. There's regulations, there's penalties, there may be tax benefits. But if you think a little bit more deeply about it, and there have been surveys about this that talk about why companies develop sustainable business plans, a lot of it has to do with your competitiveness, maintain market leadership. Increasingly, the consumer, whether it's a company buying your product or it's a John Q. Public or Jane Q. Public in a large shopping center, is looking for companies that they perceive to be more sustainable, better stewardships of the environment, yet delivering the high-quality product that are for a reasonable value. There can be efforts of continuous improvement, right? I mean, saving energy, resources, material is a good way to save money, is a good way to make your process more efficient. So even if you ignored the environmental aspects of it, it's just a characteristic of continuous improvement. You may be using materials that are at risk of disruptions in the supply chain, rare earth materials or some other material that is widely sought after, and that's a concern that can affect your your bottom line and your ability to deliver product to the customer. You might want to reduce cost of ownership for your operations. Finally, at the bottom, it's sort of like, you know, what's happening in your supply chain outside of your facility. We've seen some recent examples of things that were totally unexpected in the supply chain that had huge impacts on the ability of the factory to deliver, or the company to deliver product, and also the consumer's perception on how well that company is doing in stewarding their product through effectively and efficiently. So these are all questions that we'd like to worry about. The opportunities that are afforded by addressing these challenges are interesting, and I call them opportunities because they're essentially ways in which manufacturing, again, I'm speaking as a manufacturing person, manufacturing can address the needs. So all of the future energy, transport, et cetera, devices and systems that we're building are based on increasingly precise elements and components, different materials, complicated processes. This is a manufacturing domain. So we need to do this, develop these technologies in order to meet the needs of the future. While we are doing that, we should do it in a way which is energy and environmentally efficient. The customer is asking for it. Manufacturers are asking for it, and, you know, to the extent that it actually comes to the bottom line in terms of the cost of energy or the cost of treating waste or other products as a result of the operation, it saves us money. There's a lot of need for alternate energy systems that are being developed, and in some cases these are benchtop and need to be scaled to full-scale manufacturing to be efficient, so this is great. The machinery that makes things, you know, a machine tool company's customer is a factory and their product is a machine tool. These would like to use less energy, materials, and space. Want to have efficient operation, and of course the government regulations. So this is an opportunity for manufacturing to shine as part of an engineering activity, and linked with design then, as we're going to try to show you that we do here today, how to make the whole system much more efficient. So now I'm going to turn it over to Margot Hutchins, who is going to continue in this discussion and drill a little bit deeper into some of our activities.
Thanks, Dave. So I'm going to tell you a little bit more about our philosophy and how that sort of brought us to this engagement with sustainable mines. So as is likely clear by now, we view sustainability as having three pillars, as I bet many of you do as well: the environment, society, economy. And our goal is to ensure that our engineering graduates are able to address all three pillars through effective design and manufacturing, because there are impacts in all three areas due to the decisions that are made in the design and manufacturing phase. Arguably, because there are more degrees of freedom early in the product life cycle, engineers have the ability to significantly affect the life cycle impacts of products through strategic design and manufacturing decisions. All right. We also strive to contextualize the work that our students will do as engineers. We strive to remind them that the problems they solve are driven by human needs and desires, which also drive political, social, and economic processes. Design and manufacturing engineers provide technological solutions to address human needs, and the technological solutions that are offered, as well as the political, social, and economic processes, impact the human needs and desires and also have some impact, whether that be environmental, economic, or social. I bet many of you are very familiar with life cycle assessment. So this particular slide just outlines the general process that would be used. We try to provide our students with an understanding of life cycle assessment so they are able to understand the linkages between the choices in one life cycle phase, and the impacts in others. Because our focus is on manufacturing, we emphasize how decisions related to manufacturing impact other life cycle phases. More specifically, one of our objectives is to enable students to leverage manufacturing for overall improvements across the life cycle of a product. We hope to provide them with the ability to identify opportunities to make a relatively small investment in the manufacturing stage, which improves product performance and results in decreased impacts. Although that investment in manufacturing may create some additional impacts, there are many examples of those impacts being far outweighed by the decreased impacts in other areas of the life cycle. The fundamental concept is connecting manufacturing process parameters to part features and eventually to part function. One of our recent graduates, Munir Halou, uses surface integrity as the example of part feature, and as a subset, surface roughness as an example of surface integrity. Part function is represented by gear efficiency, which is influenced by surface roughness. The process parameter impacting surface roughness is volumetric removal rate. By selecting the correct volumetric removal rate, surface roughness can be improved, and therefore, so can efficiency. By investing slightly more resources into manufacturing, resource consumption during the use phase is reduced. Additionally, we work with students to help them understand how decisions at different levels of the manufacturing hierarchy interact within one enterprise and across the supply chain. And so I think at this point I'll turn it over to Terry for a demonstration of sustainable mines.
Thanks, Dave and Margot. I'm going to give you a quick overview of sustainable mines and how it works, so you have some context for the project work that Margot and Cindy will subsequently share with you. So Sustainable Mines was the first software company to bring ecodesign and lifecycle assessment software to the market specifically for product development organizations. We were also the first to deliver that type of software in the cloud. And you can see that we've had some very interesting uptake, not only in industry, but also in every type of education around the world. We're a mission-based company. Our mission is to operationalize environmental performance in product development and manufacturing to drive revenue and growth through greener product innovation. And so we're coupling two big ideas, ecodesign, teaching people to think differently, or lifecycle thinking, coupled with lifecycle assessment. Because when you think differently and measure those new ideas, it gets you to truly greener products. And here's where the innovation happens. It's not through measuring, it's not through doing life cycle assessment, but it's through applying technical and rigorous metrics to new ideas as they happen, as quickly or as deeply as they happen, to help make trade-offs in early stage product development to ultimately go manufacture better products. Just to re-emphasize what Dave had already talked about, there are real business drivers today creating real market demand for products with better environmental performance. And so our belief is that it is an innovation driver. When you frame product development and manufacturing in a new context through a new lens, you get new and differentiated solutions. In the software is content and tools that help product development teams, and in this case students, utilize new ways of thinking and bringing new strategies to products throughout their life cycle stage. And Cindy will actually illustrate how some of this strategy application stimulates new ideas and new thinking. It also teaches what is life cycle assessment, that it's objective and comprehensive. It's an iterative process just like design. And so when you bring iterative measurement into iterative design, it allows you to move through the design and development process in a methodological way. This is probably the geekiest slide in the deck, because we merged life cycle assessment with engineering. We developed some combined terms. So in Sustainable Mines, you don't just build a bill of materials, you build a system bill of materials, because you're accounting for all of the inputs across all the life cycle stages of a product. All of these inputs are expressed in what's called life cycle inventory data or chemical data, and when you attribute the chemical data through the lens of a methodology, can be attributed to one or more categories of impact, and each of these types of impact can be attributed to different types of damage, either to human health or to the built or natural environment. Our methodology is based on science from Tracy, which is developed by the EPA, and it looks at these 10 impact categories. We simplify the life cycle assessment process by creating a single figure methodology, and so we take the impacts from each of these categories, normalize and weight the scores to create a single figure impact factor, which is a millipoint score. We also then pull out the global warming score and interpret that as carbon equivalents so that you can do carbon footprinting. And all of our underlying life cycle inventory data is from the same trusted sources that are used in any other life cycle assessment tool. This is a key concept that personally I get quoted a lot as having said this, but it's really a fundamental concept that you have to start with, which is to debunk the idea that there is any such thing as a green product. There is no such thing. Green is a relative value, and so the only way to determine what's green is by comparison. So something can only be greener than something else. At the core of our software is this comparisons concept tab, where the user starts by benchmarking either an existing product or a first concept, and every subsequent concept or product that gets modeled is compared to this reference. And at any point in time in the product development or investigative process, you can change the reference, and then all of the scores change again as they compare to this baseline. So in fact, Sustainable Minds is not just life cycle assessment software. It's actually eco-concept modeling software with real-time life cycle assessment results. And our software is based on these three pillars of software, data, and collaboration, learning and knowledge management, and community. We knew that just building another tool would not make organizations successful. It's about being able to work in new ways, think differently, get the data that you need, learn from each other, collaborate, and share that knowledge both inside your own organization and ultimately externally in a larger community. So again, the software is designed to be able to benchmark and compare. It delivers quantified estimates of environmental performance. It was designed expressly for non-life cycle scientists to integrate into product development, and finally to create a standardized system so everybody is doing it the same way, the same methodology, the same data, the same way of measuring, and ultimately delivering those results in easy to understand formats. Now the Learning Center that sits alongside the software is quite extensive. It's maybe today the equivalent of about a 150-page textbook on how to do life cycle assessment, eco-design, all the way through results interpretation. I pull out this section about the functional unit, and you can see that in any given section there's lots of examples, lots of definition, lots of short case studies, and so there's plenty of content for students to learn on their own, but also plenty of content for you to refer to in assigning homework or reading or research projects. We also, because we're in the cloud, provide the service to develop custom data so that you can model products specific to the way you manufacture products if you're a manufacturer, or as educators, if you want to teach with a specific kind of project or product, we can work with you to add the data that you need. And a great example of that was in the last webcast. We featured faculty from the University of Pittsburgh in their chemical engineering program, Eric Beckman, where we worked with Eric to supply the data for the project he gave, which was to redesign a shampoo formulation and a fracking fluid formulation. And so I bring that up because Sustainable Minds can be used not only for mechanical products, but also for formulated products, and Cindy's going to show you an example of that. You can browse our data set to see what we have, where the data is from, and again, you can download the data request form and request data as you need it, and we'll work with you to get that added. Sustainable Minds has been used on simple products, complex products, but once again, the process yields more than a finished product. It yields real learnings that can be reused and amazing insights and amazing results. This is one of my favorite case studies, and in fact, you can watch this webcast on our website. The redesign of a very simple product, this shipping reel, yielded a new product that could be reused 36 times versus an average of 2 times with the previous design. And one of the key learnings that they reported was that using Sustainable Minds helped them stay focused and on track to a solution that actually provided not just meaningful improvements, but dramatic improvements. And Sustainable Minds allowed them to throw out preconceived ideas that they thought would yield great results that in fact didn't yield results at all. This just gives you a sense of what the interface looks like. We're in the System Bill of Materials tab. It's set up to model each stage of the product's life cycle. Here in the Manufacturing tab, the user starts by setting up all the components that they want to model. We use the terminology of mechanical engineering, assembly, subassembly, and parts. And when you open up each subassembly, you can see that it contains as many parts with processes applied as you like. The results, again, are comparative. The concept you're working on is always compared to the reference. And again, the results are easy to use and understandable. So Margot, I'm going to turn it back over to you to now talk about how you're using Sustainable Minds in your curriculum and what the students and you are learning.
Great, thank you, Terry. So just a few things about me and my background. I joined UC Berkeley in 2011 as a postdoc. I'm currently the Associate Director of the Laboratory for Manufacturing and Sustainability. I'm a research engineer here at the university as well as a lecturer, and I've had the opportunity to work with a number of different organizations, including the Sustainability Consortium and NIST and the California Air Resources Board and projects related to sustainability. So Professor Dornfeld and I co-teach a course in sustainable manufacturing. It's a graduate course. We have traditional MS and Ph.D. students in the class as well as M.Eng students, and I'll explain their graduate program in a bit more detail later in the presentation. The goal of our course is for students to understand 3 things. First, we want them to understand what being sustainable means in for-profit enterprises. Second, we want them to understand how to use the tools and techniques available to support sustainability in a design and manufacturing context. And third, we want them to understand how to communicate sustainability performance to a range of audiences. The course is divided into 9 1- to 3-week segments. So essentially, these segments fall into 3 parts. The first is providing students with a broad background in sustainability. The second is parts 5 through 8. There are 4 segments focused on major sustainability issues: energy, materials, water, and social impacts. And then the final portion of the course focuses on bringing sustainability into the professional practice of design and manufacturing. Currently, am I too far ahead? Yes, thank you. We bring Sustainable Minds into the segment of the course focused on design and manufacturing. Specifically, we use Sustainable Minds to consider how design decisions affect environmental impacts across the product lifecycle. So we have the students do a homework assignment using Sustainable Minds. They choose a simple product, develop a reference concept for that product, and analyze the results to understand the impacts, and then model at least 2 alternative designs. So this is the comparison that Terry was just discussing. We ask students to choose a simple product because the focus of this assignment is on understanding life cycle thinking and identifying opportunities to improve the impacts associated with a particular design. As you can see from this excerpt from the grading rubric, we are looking for students to understand how Sustainable Minds works, which will enable them to more critically assess the results it provides, to understand how to set up a life cycle assessment, and to consider several indicators associated with the particular designs and looking at the trade-offs among indicators and designs. Because Sustainable Minds is relatively easy to use, in 10 days the students are able to go from having no prior experience with the software to using the software as a basis for a report on the impacts of a product and a few alternatives, as well as design decisions that are linked to those particular impacts. From our perspective, this is a good fit given all of the other material that we're covering in the course. The students have chosen to examine a number of different products, from the very simple, yet very important, pizza box, to the Dornfeld stove, which is also a very simple product, but it provides great benefit to people living in regions that burn biomaterials for cooking fuel. Because this particular stove burns the fuel very efficiently, it eliminates much of the particulate that results from conventional stoves and reduces the need to collect fuel. You can see the other examples of products that students chose listed on the slide. In general, we encourage students to select products with 5 or fewer components for the assignment. All right. So as an example, oh, thank you, Cindy. The results of the hot glue gun analysis are shown here. The students quickly determined that aluminum was the greatest contributor to the environmental impacts. Their first concept replaced aluminum with steel and included a redesign of the heating element to account for differences in thermal resistance. Their second concept utilized recycled aluminum and included recycling at end of life. And then their third concept utilized recycled steel and the redesigned heating element. I thought there was 2 important insights that the students provided in their report. One was the need to design for disassembly if the steel is to be recycled at end of life. And the second was the importance in changing consumer behavior due to the impacts associated with energy use during the use phase. So certainly the students are gaining an understanding of the impacts of different materials and manufacturing processes, but through this exercise they're able to see a broader picture of the product life cycle. So the students found Sustainable Minds to be easy to use. They came away from the assignment with a better understanding of how design decisions are linked to impacts and how to implement design for environment principles. They also gained experience addressing trade-offs among different considerations. The students also gained broader insights. In one case, the group recognized that a different business model would be necessary for the proposed design to be feasible. And in another case, the milk carton example, the team recognized the importance of regulations, in particular the FDA's requirements that bottles be made of virgin materials, so recycled components were not an option in that case. As instructors, we learned that the concept of functional unit needs more explanation. We're currently developing an in-class exercise to ensure that students have every opportunity to understand that concept before we set them loose on the assignment. We found a number of interesting choices of functional unit that may not have held up to ISO 1440. We also want to provide students with the experience of the data scarcity problem, which they'll likely face in their professional lives. We want to work on pushing the students to more fully explore how Sustainable Mind works and to incorporate some of the earlier coursework on eco-design strategies. Okay. So another component of our course is the semester-long project. Everyone is in a team of 3 to 5 students, and you can see the major milestones of the project here. In general, we are looking for the students to come out of the project with a report that could easily translate into a conference paper or journal article. So we do require a literature review, an explanation of methodology, the impact of the proposed project. based on our philosophy, we also require that the students consider the triple bottom line and look at the life cycle impacts of a product, its system, and the processes involved. There we go. Oh. There, okay. So one example of a semester-long project that incorporated sustainable mines was the soccer ball project. And in this case, the students were comparing the environmental, social, and economic impacts of 4 different soccer balls. One was just a standard soccer ball. The second was a fair trade soccer ball. And the third was the socket soccer ball, which I believe came out of MIT. And the gist of it is that the socket soccer ball generates energy during its use, which is stored in a battery. It has an outlet, so the energy that's stored in the ball can be used later to light a lamp or something like that. So the students were seeking to quantify the environmental impacts of the soccer ball using sustainable mines and identify which life cycle stages contribute most significantly to environmental performance and identify new designs that would improve that environmental performance. Okay. And so the students found that transportation and end of life are the greatest source of impacts. Transportation, because many and or most soccer balls are created in Pakistan, and so there's a lot of transportation costs associated with those balls. They found that using recyclable materials would improve the impacts by about 45%, which is fantastic. And there was a big difference with the socket soccer ball because of its electrical components. Its biggest impacts were in the manufacturing phase. And so you can see the students put together a relatively simple table looking at the trade-offs among the different impact categories for the 3 different soccer balls. For the environmental impacts, they were virtually the same for the standard and fair trade soccer balls, whereas the socket had lower environmental impacts overall. So the trade-off with that fair trade ball is that it has an improved social performance because it addresses worker rights and working condition issues. It does have a slightly lower economic performance than the standard soccer ball. Excuse me. And then the socket soccer ball, the economy of that particular product is a little unclear. It's primarily being distributed at no cost to the users, which isn't a great business model, but that may change over time. Okay. So the students recognize that there's different trade-offs for each type of soccer ball. And I thought that one of the insights that came out of their report is this quote shown on the slide. And their goal was not to instruct consumers to make a choice A instead of choice B, but to educate them on the impacts of their decisions. So to allow consumers to understand that there are many different soccer balls on the market, and the consumer themselves needs to kind of weigh their values in determining which soccer ball is the right choice. Okay. So quickly, I'm going to go through a little bit more information about this M.Eng program we have here at UC Berkeley and how sustainable mines was incorporated into some of the Capstone projects there. So M.Eng is a Master's of Engineering program that falls sort of between a traditional Master's of Engineering program and an MBA program. It's looking at developing leadership and technology expertise in these students. And they have a T model curriculum where they attempt to give the students breadth in leadership and business strategy, management, and so on. But they have depth in some technical area, as well as depth developed through a Capstone project, which is a project that covers the 2 semesters the students are engaged in the program. And I'll go very briefly through these learning outcomes. So we're looking for the students to integrate business and technical skills, to be able to formulate the need that technology might address, identify stakeholders affected by a particular solution, make trade-offs among those stakeholders, develop engineering solutions to the needs that are developed, communicate their solutions to stakeholders, and coordinate, a little bit of slide issue here, and coordinate a project with team members with diverse backgrounds. So the student group that incorporated Sustainable Minds was working on a project for Siemens, improving the performance of a wind turbine blade, and they were able to add on some triple bottom line assessment through the use of Sustainable Minds, looking at cost of raw materials, social impacts of toxic metals, and then environmental impacts through the millipoints generated by Sustainable Minds. And you can see the results of their analysis here in this table, where they identified that some particular materials had better economic and environmental impacts than others, and some materials had more negative social and environmental impacts. So I think in looking at how Sustainable Minds was incorporated in the Capstone project, it was definitely an add-on to their core objectives. And I think that we need to be more careful in how we structure the use of Sustainable Minds to ensure that the students have effective learning opportunities when it's used in this particular context. We want to make sure that the students are able to understand how the software works and do some critical analysis, and ensure that the students are using correct life cycle thinking and present the results in a meaningful way. The students in the Capstone project did gain experience with life cycle thinking, became more aware of the trade-offs among impacts, and began to understand opportunities in design to affect the impacts of manufacturing and the entire product.
So I was going to jump in here just to make some kind of summary comments about how we incorporate sustainability into manufacturing. A lot of it is definitional. A lot of it is trying to get people to understand how you measure and characterize the functioning of these systems and include the use of materials and resources, and then their environmental or their sort of green aspects to it. Usually we have to make sure that we have a comprehensive systems approach. In other words, don't just focus on one particular aspect. One should look at all aspects of it as you go from the process or the facility on down to the tooling. We want to make sure we hit all the real requirements for manufacturing, performance, quality, and cost, but also be able to add an element of environmental impact that fits in along with those as just part of the analysis. So this holistic approach really gets everyone to think about manufacturing in the process life cycle, whether it's for the product to be manufactured or whether for the product that's being used. The did I skip one? Okay, sorry. Things like leveraging, that is making the argument that if you do the right thing at the manufacturing phase gives you a tremendous benefit over the range of the operation of the product if manufacturing cannot be seen to be a major impact on the product life cycle. So that's something that is a great way to tie in fundamentals of engineering, especially manufacturing and design, into the analysis as technique. We need to have data-driven tools. That's something that our lab is working on. That's something that Sustainable Minds certainly offers, but this has to be kind of broadened over the widest range of design and manufacturing. These tools then form a part of a larger framework for sustainability, establishing key performance indices, helping us to define system boundary and scope, how to build tools. We try to prepare students for industry because this is an increasing interest of companies that hire our students, or if students go on to further graduate studies or academics, as a piece like ethics that needs to be integrated throughout the curriculum. So modules that can be created using tools like Sustainable Minds and other techniques are very helpful in getting those points across. They are very effective in engineering practice courses, that is, as opposed to, say, a theoretical computation of materials course, may not be as effective as in the kind of design courses and manufacturing courses with case studies and projects that we've been talking about. We're working on integrating this at the undergraduate level because we think that this would really be very beneficial to get students thinking. We probably would have to have more background material to get them scoped to that, and the projects would need to be more structured. Usually in a university environment, things trickle down from the research level to the graduate level, then to the undergraduate level, and that works pretty well. And we're sort of now in the trickle phase to the undergraduate curriculum. I think if you're an industry person looking at universities in general that do this, or Berkeley in specific, we are working on a strategy that ensures that all of our engineering students have an understanding of the sustainability aspects, measurement, impacts, assessment as part of a design and manufacturing curriculum, which is important for our accredited program, our ABET accredited program. We have found in our own experience, both at the graduate and undergraduate level, that companies are increasingly interested in hiring folks with this kind of a background. They still want fundamental core engineering skills, but some sensitivity to or awareness of or competency in life cycle assessment and sustainability thinking is very useful. Through things like the Capstone courses and course project, students find ways to actually sort of functionally integrate these with their normal education, and that's very good. So I'm going to turn it over to Cindy now, who's got the task of finishing up the discussion today.
Thank you, Dave. So hello, everyone. I just want to say it's an honor and a pleasure to be speaking on this webcast today. Currently, I'm a grad student at UC Berkeley, and I conduct research in LMAS with Margot and Dave. And as Terry mentioned earlier, I've also interned with Sustainable Minds for 2 summers. Oops, sorry about that. All right, so today I'm going to be presenting some ideas for next iteration projects for the course we've been discussing today, Sustainable Manufacturing. And this came about as a result of some early discussions about how to better integrate Sustainable Minds, and also from some of my experiences this summer as an intern. So the big picture of this is that it would be a series of weekly assignments that would have varying levels of complexity and different takeaways for sustainable manufacturing and reveal different trade-offs. And to put this in context, here are the course modules where I see this being most applicable. And as Margot covered today, we currently first introduced Sustainable Minds in that homework assignment where we asked students to model a simple product. And as a next iteration, she mentioned we wanted to include some more exercises around students' understanding of millipoints, make it clear to them that Sustainable Minds uses Tracy methodology, and also ensure that they really have a proper and correct understanding of functional unit. And this is something that I still currently struggle with myself. So I wanted to bring to your attention, Terry had mentioned the Learning Center, and there's a page devoted to functional unit, and there's some examples, and they're also correlated to product types, and I'd encourage you to direct your students there. And now I'll present a sample assignment as it might be integrated into this module for materials in manufacturing. And I've required the students to model a telescopic slide to learn where the impacts are and what's causing them. And I give the students a spreadsheet of instructions and the bill of materials. And they're asked to model the concept with a variety of different materials and given a starting point for different manufacturing processes. And I'd like to note that whenever you're working in Sustainable Minds and you don't see data that you need, that we encourage you to submit the data request form, and the team will look to see what's publicly available, and if it's there, they'll actually add it for free. Okay. All right, and the goal of this project is to teach students to create proxies, and today I'll be providing a specific example of industrial grease, and also to understand different trade-offs, whether that's between different materials, different manufacturing processes, and also product lifetime and its effect with design and environmental impact. Okay, and here you can see an overview of this telescopic slide, and I should say that this project was inspired by an experience that I had this summer working with customer support, where there was someone who came to us and was modeling exactly this product and had a lot of questions, and we felt that this was a great opportunity and exercise for students. And here you can see the different information that they'll need to create the SBOM. Okay. So creating a proxy. In this case, I'm requiring them to create it for industrial grease. So and I've outlined the two different options. The first is to look what's currently existing in sustainable mines and pick the entry that's most similar. But a second option is to actually dig into the data and model industrial grease given its raw components. And here you can see a generic formulation for grease and also each item aligned with what's currently available in sustainable mines. And I feel that this is really a great opportunity and exercise for students because oftentimes they don't really think about grease as a product and that it has a BOM and it has components to itself. So it really is a good chance for them to dig into the data. So here you can see the view in the manufacturing stage of what this would look like. And you notice that the icon for industrial grease is different than the others, and that's because it's a subassembly, and Sustainable Mines has this functionality. And you can treat this as a container that you might mix a recipe within versus the others as specific parts that have only one material in different processes. And this is the results view. So in this case, it's showing us that material selection, specifically the choice of steel, is contributing greatest in this life cycle to its impact and would then be the focus of redesigns. Okay. So here are some questions that you could pose to students. So how can they reduce the impacts of material use? How does material selection and product lifetime interrelate? And then given different scenarios about use or product lifetime, how would it be designed differently? And this would also be a great opportunity to redirect them to the Learning Center and the Ecodesign strategy wheel and examine lower impact materials. And this is a snapshot of what this concept looks like compared to some of the alternatives, and you'll see that they're benchmarked to the reference, and there's a variety of different materials, and the functionality to point out here is the copy concept functionality, and which makes building this project really easy when you only change a little bit about each concept. Okay, and so that concludes the specific example, but this is a list of some others that I came up with while I was working on this, creating scenarios or comparing to market competitors, doing a comparative problem, trying to answer which is better, the questions which is better, paper versus plastic. And just to wrap up, I want to introduce the Sustainable Mines Curriculum Library, and this is a collection of examples of syllabuses and student and assignments for students, and we've been collecting these for about a year now, so if you feel that these would be helpful for you, please let us know and we can send you some. Okay. Thank you.
Well, thank you so much, Cindy. That was a great summary, and we miss you already. And so, again, to wrap up, I think Dave and Margot and Cindy have done a great job to show that the skills that are now required to teach engineers and designers to get good jobs ultimately in the marketplace need to be taught in school now, and it means that educators are continually creating new types of courses and new types of projects using new kinds of tools, and it's also important to recognize, and I think this is a great example, that everybody is figuring this out right now. You know, Dave, Margot, Cindy, continually trying things, iterating, learning new stuff. As the market needs increase, the response in education needs to step up to meet that demand. To wrap up, we want Sustainable Minds ultimately to be used in every school, in all types of curriculum. We make it very easy to get started. You can get a free trial. You can purchase from the site. We have quantity discount programs for class sizes, departments, even site-wide programs. We have special support and training packages for education. We can help you create a course, a project, create custom data. And we invite you to visit our blog where we have the webcast replays and pretty extensive write-ups of each of the webcasts that we've had to date featuring educators from business design and engineering who have been teaching with Sustainable Minds and have done the same thing that you saw Margot present today, talk about their school, the course, the project, show examples and the learnings acquired by the students and by the educators. And this webcast will also be posted on our blog along with a write-up. And for those of you who are interested in getting this slide deck, we're happy to send it to you. I think you can indicate that there's some questions on the exit. When you exit the webcast, you can respond, let us know. If you'd like the deck, we'll follow up with some of you who have indicated that you'd like us to do that. And in the couple minutes, we are at the top of the hour, but for those of you who have a few minutes to still hang out, we'll try to respond to some of the questions that have been submitted. And again, for those that we don't get to, we'll follow up with you offline and address your questions there. So the first question, Dave, was directed to you, and this was before Margot and Cindy showed their work, but particularly was interested in design projects that focus on maximizing options for material reuse and recycling of used materials at the end of life. Is there any particular focus on those types of projects?
It's a great question. So there is, and it kind of breaks down into a couple of categories. So category number one is, are you going to be taking something apart and then trying to recover materials for recycling or resmelting or returning back to some newer or as part of a mix in a newer product? There's a second category, which is essentially taking things apart as you would be if you were recycling electronics and trying to harvest some of the materials to be used straight off. There's a third category, and we were just at a conference in Copenhagen where it was a great presentation where you take something apart and you use the material not as the input to a sort of a resmelting and reformulating process, but you use the material as the input to another stage of a manufacturing process that gives you an output that uses that material as the input. For example, if you take a fender off of an automobile, could you in fact extract enough flat material from that, either using a hydrostatic forming or some kind of a forging process, to create another metallic component that could go back on the automobile without having to go through the entire recycling process, that is the smelting and the casting and the re-rolling and the stamping, etc. So we look at kind of three different categories of that. Some of them are basically, if there's something called the RICO Comet Circle, which some of the listeners may be familiar with. If you Google RICOH Comet Circle, it'll pop right up, where they talk about different paths. And the idea is to try to get the path back to successful reuse with the least amount of material processing, transportation, handling. So yeah, I think the idea of reusing materials or recycling materials, other than just sort of shredding it and blowing it into a furnace someplace, is very important, and this reflects the design functionality. Margot mentioned some cases where there are restrictions because of FDA and you can't put things in other things for different kinds of products, or reflects the manufacturing technology that might take materials that have been previously used and repurpose them without going through a back to the ore recycling process.
Thanks, Dave. There was another question that was directed to you. A statement and a question. Are you aware of the 4 pillars model of manufacturing knowledge that was introduced in the SME white paper Workforce Imperative in September of 2012? And if you are aware of it, have you integrated it into your sustainability curriculum?
Yes and no. Very simple. I am aware of it. The way you integrate things like that into your curriculum is to sort of compose modules or components or topics in lectures that reflect those. I would say we're probably structuring that. This is essentially the third time that we're going to be teaching the course, the third time this spring. And we're looking at how to structure it in a way that makes both intellectual sense to the students, gives them a right balance of computational and practical training, and then also adds these other components to it. So I think it's a great suggestion. I would certainly encourage anyone to take a look at that, and we are in the process of doing it. I don't have any good examples of how we've done that so far, however.
Okay, the next question is a really good one, and I'm glad it was posed. And the question is, how do you see industrial designers working with engineers, especially when both are using a life cycle assessment methodology?
So I can make a little comment that I would let either Margot or Cindy. I think, there's always this discussion about, 80% of the cost of a product is instituted in the, or cemented in during the design phase, and then it's kind of manufacturing. It's just sort of an add-on. That's always bothered me because it sort of makes manufacturing look rather trivial. I think what's really happening, and we talked to some folks from Samsung, a former student of mine, who sort of talks about design for manufacturing, manufacturing for design, where there's actually a much more integrated discussion, iteration loop between design and manufacturing. And if you think about some of these software tools that allow you to sort of look from design towards manufacturing, predict problems, or at least anticipate problems that you're going to have, and going from the manufacturing characteristic or feature to product functionality, but also to look at back up that tube from the manufacturing perspective and say, what is it that the designer could have done that would make my life simpler? I think that's where the discussion has to be. And a lot of this is to integrate the very conceptual aspects of industrial design, where you're really trying to create something that has a certain functionality and excitement to meet a need for the consumer, to the practical, more nitty-gritty aspects of actually turning it into a real product. I mean, I'm going to turn it over to Cindy or Margot. Both of them have worked in this area, Cindy especially, and maybe she has some follow-on comments.
So just to add on to what David said, this is Margot, and I see it being a little bit iterative, and I also see it as being dependent on how the organization is structured. And I have a pretty strong quality engineering background, and there's at one point, quality was someone's job, and there was one person who was responsible for it, and there was a shift in thinking that quality needed to be integrated into everyone's work. And I think this is similar, that sustainability needs to be everyone's job, and in many cases that means teams of employees with diverse backgrounds. So certainly the industrial designers need to be working with the manufacturers, as Dave said, to both design for manufacturing and to manufacture for design, to ensure that you have the manufacturing capability to implement the design as conceived.
And just to chime in quickly, I think in taking this into the classroom too, it's also a good opportunity to try to mix multidisciplinary teams, and that can lead to good learnings, and because different people have different priorities for design. So it's good to get them all working on a same goal.
Yeah, just to jump in on that comment, Margot and Cindy, we've taught an untold number of workshops, both on-site at a manufacturer as well as open public workshops. And without exception, the teams who work on a project that are comprised of both designers and engineers develop the best, the most innovative solutions, because everybody is ideating and collaborating at the same time. And so there's business model ideas, there's functional ideas, there's new use ideas, and when those ideas are being developed and contributed by all the people involved and all the different perspectives that need to be brought into new product development, that's when innovation really happens. And I think there's again, going back to the shipping reel project that I showed you earlier, that was a great example of truly multidisciplinary team and approach that was able to rethink and move a product forward really in exponential steps rather than just incremental. And I would even go one step further, which is to say that when there's not an industrial designer or designer present in early stage product development, the more radical kinds of ideas don't get considered. So we highly encourage multidisciplinary teams, interdisciplinary courses, and I think that's an exciting idea to close this webcast with today. I want to thank Dave, Margot, and Cindy for taking the time to be with us today and to have put the effort into putting this presentation together. I learned a lot, and I hope you did too. Some of the parting comments of folks who have dropped off already have confirmed that. Great webcast, learned a lot, and I hope all of you who have stayed on past the hour, we appreciate that, and I hope you've enjoyed what you've learned and that you've also learned a lot and are interested and excited to take what you learned into your schools and into your businesses. And with that, thanks again, Dave, Margot, and Cindy, and that wraps up our webcast for today.
Our pleasure. Thank you, everyone.
Bye.